In lesson 3.1b, we're going to be continuing our use of the chain rule, but we're going to be pulling numbers not from given functions, but from given graphs and from tables of numerical values. And so we're going to see how you apply the calculus rule first, and then you pull the values off of the graph or the table. One of the biggest mistakes I often see with students who are working on things is that they try to do the calculus or try to use the numbers before they do the calculus. So calculus always comes first. All right, so here are two given tables. The graph of f of x is on the left and the graph of g of x is on the right. So we're going to start with section A, and we're just asked to find f plus g. Not the derivative, just f plus g. So the rule for that is to find f of -3 and add to it g of -3. So this is just a simple matter of reading the graph and pulling the answers off of that. So f of -3 is right here, and on the g graph we have right there, and so we're looking at f of -3 being -3/2, and then g of -3 being -2, and so those two things added together are -7/2 for that value. And that's just reading the chart. Part B is asking for f plus g prime. Now when you're adding derivatives, you add them separately. So that would be f prime of -3 added to g prime of -3. Now the prime values are going to be the slopes at these two particular points. So we want to find the value of the slope on the f graph at that section and the value of the slope of the g graph. So the f graph has a slope, a rise over run on that section of up 3/2. And the g graph has a rise over run of 0. So that's 3/2 plus 0 or 3/2. Now let's work on multiplication. For part C, the multiplication rule for fg1 is simple multiplication. So that means we're going to take f of 1 and multiply it by g of 1. So let's go to the graph and find where those values are. So f of 1 is right there on the g graph, and g of 1 is just below the x-axis. So that's going to be the 5/2 times -1/2. So we get -5/4 as our value. However, fg multiplication prime is a whole different rule. You don't just do f prime of 1 times g prime of 1. That's not how the product rule works. In derivatives, we have to make sure that we're following the whole product rule. So that means we'll need f of 1 unchanged times g prime of 1. And then we'll need g of 1 times f prime of 1. That means we're taking a combination of the y value and the slope value. So f of 1 was 5/2 off of the chart. G prime is the slope right here. And so the slope of that linear piece is up 3/2. And then we'll add to that g of 1, which we know is -1/2, and f prime of 1, which is the slope value here, which is down 1/2. So we're getting 15/4 plus 1/4. So 16/4 or 4. The final section is the composite. Now the regular rule for a composite is that this means f of g of 2. And when you work on composites, not on derivatives of composites, but when you work on composites, you work inside out. So we want to find g of 2. So I'm going to go to the g graph. I'm going to find g of 2, which happens to be 1. So this will become f of 1 and we switch over to the f graph, we already know f of 1 is 5/2. But when you do composite derivatives, you got to follow the chain rule of outside in, not inside out. So this would be the outside, f prime, with the inside remaining unchanged, and then g prime with the inside remaining unchanged. And you do not do the derivative of 0, okay, because that would wipe out the whole problem. We only take the derivatives of differentiable functions, and 2 is a constant. It's not a differentiable function. It doesn't have an x in it. And so we do not do, we stop with the chain rule on its first 2 pieces. Okay, so we want to have g of 2 again. Well, that's still 1. So this would be f prime of 1 times g prime of 2. F prime of 1 was the slope on the f graph, and we remember that to be -1/2. G prime of 2 is the slope of this linear piece going through 2, which is still up 3/2. So we get -3/4. So that's reading a graph and making sure that you are applying the correct rule at the correct time. When you're given a table, again, the temptation is to start dropping numbers in right away. Like I often will see people drop this number, right into there. But that's not what you do first. You have to evaluate the derivative and then drop the number into the derivative that you get. So let's find the derivative of part A. And I'm going to use the chain rule, and I've got 1, 2, 3 pieces. So my chain rule says f prime first, and then g of x remaining unchanged, and then g prime with x remaining unchanged, and then 1. Now I'm going to drop the number 2 into both x values. So derivative first, and then substitute in your value. So I'm going to have a 2 for both of those. Okay, now I'm going to read the table. I want to start with what the value of g of 2 is. Let me erase these arrows, clean it up a little bit. All right, g of 2 on the table is right here. And so this becomes f prime of then 2, and then g prime of 2. F prime of 2 is 1/3. G prime of 2 is -3. And so I get -1. For part B, you're going to want to think of this expression 1 over g squared of x. You probably want to think of that differently. So rather than think of it as a fraction, I would encourage you to think of that in parentheses, and that would be g of x to the -2. That way you don't have to use the quotient rule. Okay, so it's reciprocal, so it's a negative power, and then the -2 goes on the outside. Then we're going to take the derivative. So -2 goes in the front because it's the outside power. We're going to leave g of x alone on the inside, and we're going to decrease that to -3. Then we're going to work on the inside, which would be g prime of x, leaving the x alone, and then times 1. Then, once I've finished the derivative, then I'm going to go and plug in the number 3. And so the number 3 will go in to both x positions here. So I'm going to put 3 in for both of my x values. Okay, so that will give me a 3 here and a 3 there. then I refer to the table. I'm going to start with g of 3 off the table. That's -4. So I'm going to have -2 parentheses -4 to the -3rd. And then I'm going to do g prime of 3, which is 5. So I end up with -10 over -4 cubed, or -64, which will reduce to +5 30-seconds. Okay, moving on to letters C and D. For letter C, we're going to want to think of this as parentheses f of x to the half, so that we can write it as a power and then apply the chain rule from the outside in. All right, so we'll do part C. The derivative from the outside in is 1/2 f of x to the -1/2 times the chain rule of f prime, leaving x alone, and then times 1. And then I'm going to evaluate this at the number 2. So after I've taken the derivative, I will substitute in the value of 2. So let's find f of 2 first from our chart. F of 2 is 8. So this will give me 1/2 times 8 to the -1/2. And then f prime of 2 was 1/3. So altogether, this gives me 1/6 times the square root of 8. If I simplify the square root of 8, that would be 1/12√2. Now you don't have to rationalize that, but you do have to simplify square roots. For the very last one, we're going to need to rewrite that in parentheses several ways. So the first way is to get rid of the square and put parentheses around that, and get rid of the square on the g and put parentheses. Right. Then, after that, you're also going to want to take care of the square root. So let me give myself a little space to work here. And so I will have parentheses, and then another parentheses, f of x quantity squared, plus parentheses g of x quantity squared, and then around the whole thing, I'll have the 1/2. And so now I can use the chain rule where I do the outside power first. So that means 1/2. And then inside I still have all these other nested parentheses. So I leave that unchanged, and then I get -1/2 as my new power. Now I'm going to chain rule on that. So now I'm focusing on this part of it. So I still have a 2 power, which will come to the front, leaving the inside unchanged, decreasing the power to 1. And then it has its own chain rule of f prime of x, and then times 1. And then plus. And then I'm going to add to that the derivative of g of x quantity squared. So 2 times g of x, the inside left alone, to the first, times g prime of x times 1. So there were a lot of nested parentheses going on that overall equation. Okay, now I'm ready into all of that to drop the number 2. So I'm going to be doing that 6 times. 1, 2, 3, 4, 5, 6. So the number 2 gets dropped in after I've done my derivative. So this will be 1/2 times f of 2 was 8. So So this would be 8 squared. And then g of 2 was 2. That's all to the negative 1/2 power. Then I have 2 times 8 times f prime of 2, which is 1/3, plus 2 times g of 2 times g prime of 2, which is negative 3. So all of that needs to get cleaned up. So 1/2 times 64 plus 4 to the negative 1/2 times 16/3 minus 12. So we're looking at 1/2 times 68 to the negative 1/2, and then 16/3 minus 12 is 16/3 minus 36/3, so that ends up to be negative 20/3. So altogether, what's left in my numerator is negative 20. What's left in my denominator is 6 and the square root of 68. So that can be simplified into 2 rad 17. That's the square root of 4 times the square root of 17. Which can again be simplified, and we've got negative 20 over 12 rad 17. So that's negative 5 over 3 rad 17 is the answer to part D. So when working with tables and when working with graphs, it's important to follow the derivative rules first and then retrieve the numbers, either the values, either from the graph or from the table itself, and evaluate that second. Have a great weekend, and I'll see you guys next week.